So these are the notes for section 1.7, which is solving one-step equations. And what we had talked about was kind of taking a mental field trip to elementary school and thinking back to about third grade and seeing an exercise that looked something like this. And your elementary school teacher asked you what belongs in the box. And as we sat in class, all of you said, oh, it's 4. And I said, how do you know? And they said, well, in elementary school, we had to memorize all of those fact families. So we knew that if you added 4 and 5, you got 9. I said, yeah, that's awesome. That's exactly how that went back then, exactly how it goes now. Now let's fast forward, maybe to middle school, or maybe your freshman year in Algebra 1, and you were given an exercise that looked something like this. Okay? And for a lot of my students, once they saw, a letter mixed in with their math, that started to cause a little anxiety. Okay. But what I want to remind you is this X is a variable. It stands for an unknown amount. This empty box stood for an unknown amount. Your third grade teacher was really teaching you algebra. They just didn't let you know that they were. So these are saying basically the same thing. Our question is, what value can I replace this box or this letter with to make this a true statement? So we want to remind ourselves just for a moment what it means to be a solution, right? Solution is the value of a variable that makes a statement true. So the value of a variable that makes a statement true. So when we use solution outside of class, we usually just mean it to mean the answer. In algebra, it has a specific meaning. What is the value of the variable, in this case, X, that makes this statement true? So how do we go about doing that? Well, if we think back of what we've done previously, and during class time, several of you told me, hey, we're going to subtract 5 here. Well, why are we subtracting 5? So you've got 2 tools or 2 tactics that you can use to solve equations. The first one is called inverse operations. You might have had a teacher say, we're going to undo whatever's been done to the variable. So X plus 5 is added to it. We're going to subtract 5. So addition and subtraction are inverse operations. Multiplication and division are inverse operations. The second piece is this. If I just think about subtracting 5 on the left side of this equation, I'll get X by itself. Positive 5, negative 5 is 0, right? X plus 0 is just X, right? But if I take 5 off of this side of the equation, we want to think about what the equal sign means. Back when you were in grade school, all it really, to us, meant was, well, this is where the answer goes, okay? If you were given a big, long worksheet of 3-digit addition problems, equals, that's where the answer goes. But for us now, the equal sign is making a statement. It says, without question, the expression on the left side and the expression on the right side, no matter how weird they look, have the exact same value. So if I take 5 off of this side, that changes the value here. If I don't take the same off of this side, now I've got a problem. Now my equation is no longer in balance. Makes that equal sign a liar. So we can't do that. So we have a tool called the properties of equality. So if you ever had a teacher remind you to do the same thing on both sides when you're solving an equation, they were referring to the properties of equality. There's 4 of them. There's the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. They all say basically the same thing. I have this equation that's in balance, X plus 5 equals 9, and I subtract the same value from both sides. My new equivalent equation will still be in balance. So 9 minus 5 is 4. Okay? So this is the properties of equality. So now I've got my variable isolated. I have nothing else on the left-hand side except X. Awesome. Whatever happens on the other side, that's my solution. Now, here's the thing. You're always going to get, x equals some number. Okay. How do we know it's the right number? Well, if this is my solution, if I substitute it back into this expression, it should make a true statement. So is 4 plus 5 equal to 9? So I simplify the left side, and I see that it's obviously 9. So that tells me that 4 is our solution. So let's take a look at some of the example problems that we saw while we were working on the Desmos activity. So we had one that looked like this. Now, this is a two-step equation. We took a little bit of a step forward because we seem to have a good handle on one step. We're going to hold whatever term as the variable for last. We're going to pick the other term and use our inverse operations to simplify that side. So I have 4x plus 2. I'm going to subtract 2. Okay. Positive 2, negative 2, I combine those, I get 0. So the left side is just 4x. X is multiplied by 4, so we're going to divide by 4. 4 divided by 4 is 1, so I get 1x here. 20 divided by 4 is 5. Okay. Go ahead and pause the video and take a minute to try to work out this equation on your own. We all came up with a value for this, but I'd like to see what happens if you go through and do the steps on it. All right, so let's take a look, and you can check your work here. So we had said that we had 1/3 times x equals 9. So I want to divide both sides by 1/3. I recognize that dividing by anything means I can multiply by its reciprocal. So the reciprocal of 1/3 is 3. I'm going to multiply by 3 on both sides. 3 divided by 3 is 1, so I have 1x on the left. 9 times 3 is 27. Let's look at that last example. We had 2 times the quantity, x minus 1 equals 10. And a lot of us, as soon as we see this, we go, oh, distributive property. 2 times x is 2x. 2 times negative 1 makes negative 2. And then I have equals 10. Awesome. So now this is exactly a two-step equation like we did over here. I'm going to save my 2x for last because that's the term that has the variable in it. I'm going to add 2 on both sides. So now I have 2x equals 12. And dividing by 2 on each side, x equals 6. The example that we looked at in class as an alternate way to achieve this, to work through this problem, is we saw that on the left side, I have two things multiplied together. They're factors, right? 2 and times the quantity x minus 1 equals 10. So I also noticed that 10 has a factor of 2 in it. 10 divides by 2, and this side divides by 2. So as long as I have that situation in place, I can actually divide both sides by 2. So I'm going to divide out that factor. And now I have x minus 1 equals 5. And it's a hop, skip, and a jump to get to x equals 6. So this was a quick refresher on the process of solving equations. When we did the 3-2-1 summary and we talked about the 3 big ideas, to me personally, these 3 things here is what makes the world go round when it comes to solving equations. Keeping in mind that we're looking for a solution, the value of a variable that makes a statement true. And we've got 2 tools that we can use over and over as many times as we need in order to accomplish that. Inverse operations, so multiplication, division, addition, subtraction, to undo whatever's been done to the variable. And the properties of equality. That tells me if I start with an equation that's in balance and I do the same thing on both sides, add 4 to both sides or divide by 3 on both sides, that my equation remains in balance. So those are the 3 biggies that you want to take away from solving equations. And we'll keep using these skills, solving equations and manipulating equations all the way through until the end of the school year.